Next topic is a differential equation reducible to exact differential equation. So first is the definition of integrating factor. A differential equation which is not an exact differential equation but can be reduced to an exact differential equation by multiplying the equation by some function of x and y, say mu xy, denoted by mu xy. Then such a function mu xy is called integrating factor and shortly denoted by I dot f dot, integrating factor of the differential equation. That is, the given differential equation is not exact differential equation. We know that when the differential equation is exact differential equation, if dabba m by dabba dabba m by dabba y is equal to dabba n by dabba x. Okay, that is the derivative of m with respect to y and the derivative with respect to n of with respect to x. These two are equal, then the given equation is exact. But if these two are not equal, means the given differential equation is not exact differential equation, because dabba m by dabba y is not equal to dabba n by dabba x. In that case, we can reduce the differential equation to exact differential equation by multiplying some function of x and y, and that factor is called integrating factor. That is, integrating factor is what is the factor or is the function of x and y by which if we multiply the given differential equation, then it becomes a exact differential equation. For example, consider an equation y dx minus x dy is equal to 0. So compare this equation with m dx plus n dy is equal to 0. M is y, n is minus x, and then dabba m by dabba y is 1, and dabba n by dabba x is minus 1. These two are not equal. Dabba m by dabba y is not equal to dabba n by dabba x, and hence the given equation is not exact differential equation. This differential equation, equation number 1, is not exact differential equation. It will be shown that this equation number 1 can be reduced into exact differential equation by multiplying the equation 1 by x into y, or 1 by y square, or 1 by x square. If you multiply any one out of these three, then this equation becomes exact differential equation. So these three are called integrating factors. So we, for non exact differential equation, we may have more than one integrating factor. So these are the three integrating factors. So suppose that we multiply the equation number 1 by x into y, then what happens? It becomes 1 by x dx, because y divided by x into y is 1 by x, and then x divided by 1 by x divided by x into y is 1 by y. And then what is m now? 1 by x, and n is minus 1 by y. And if we find dabba m by dabba y is 0 and dabba n by dabba x is 0, and therefore dabba m by dabba y is equal to dabba n by dabba x, and therefore this equation number 2 is exact differential equation. And we know that how we can find then solution of this exact differential equation. The general solution is what? Integration m dx. Now m is this. In this new equation second, m is this 1 by x and n is minus 1 by y. And then apply the formula of finding general solution of exact differential equation. What is that formula? Integration m dx plus terms in n independent of x dy is equal to constant. So m is 1 by x dx plus terms, integration terms in n independent of x. There is only one term, n in n, and it is minus 1 by y, and it is independent of x, and therefore take that term minus 1 by y. Dy is equal to c1 or c as a constant of integration. And then 1 by x, if integrating m dx means that dx means x is variable, treat y as constant, and so 1 by x integration is log x minus 1 by y is log y is equal to c1, and then log c1 as a constant of integration, and then we have log x by y is equal to log c. We replace this c1 by log c, and then x by y take cancel log of both sides, so x by y is equal to c, or we remain c1 as it is. Then log x by y is equal to c1 means x by y is equal to e raised to c1, and suppose that e raised to c1 is new constant c, and therefore x is equal to cy, which is the general solution of the given differential equation. So how we can solve these non non-exact differential equation. The given differential equation is not exact, but it is reducible to the exact differential equation. That is, for the given differential equation, dou m by dou y is not equal to dou n by dou x. But after multiplying some factor, some function of x and y, the given equation reduced to the exact differential equation. So this type is what? A differential equation reduced or reducible to the exact differential equation. So, and if you multiply by 1 by y square, then also this equation y dx minus x dy becomes a exact differential equation. And so if you multiply by 1 by x square, then also this differential equation becomes a exact differential equation. So for interest, we can solve this for find the solution of again by multiplying 1 by y square and 1 by x square. So if you multiply by 1 by y square, then the given differential equation becomes y by y square means 1 by y dx, and this x by y square dy is equal to 0. And then dou m by dou y is minus 1 by y square, and minus x by y square is derivative with respect to x is minus 1 by y square. So if you multiply by y square, 1 by y square, then dou m by dou y and dou n by dou x both are same, and it is equal to minus 1 by y square. Minus 1 by y square for dou m by dou y and dou n by dou y and dou n by dou x both are 1 by minus 1 by y square, and that is these two are equal. And what is the solution of this differential equation now? So y dx minus x dy divided by y square, and we use these tricks. Y dx minus x divided by y square is derivative of x by y, and then we write it as the derivative of y by x. So instead of this formula, we can directly find integration by integrating. So y dx minus x divided by y square is derivative of x by y. Then integrating both sides with respect to integrating both sides, then we have x by y is equal to x by y is equal to c1 or c constant, and then we have again x is equal to cy as the final answer. So use this trick or use the formula integration m dx plus terms in n independent of x dy is equal to constant. So by both the method, we have the answer x is equal to cy. So by if we multiply by 1 by y square, then also we have the we see that the given equation becomes a exact differential equation. And y dx minus x divided by y square, we can write it is equal to d of x by y, and then integrating both sides, we have x by y is equal to c, that is x is equal to y. So this is about one. If you multiply by 1 by x square, then we have to use this trick, y by x, x dy, y dx, there is y dx minus x dy divided by x square is the derivative of y dx minus x dy is the derivative of minus x by y minus y by x dy. Here is the what if you multiply by x square, 1 by x square, then y dx minus x dy. So y dx minus x dy is minus x dy minus y dx divided by x square is derivative. That is, if you multiply by 1 by x square, then it is a derivative of minus y by x, and then is equal to c after integrating. So we have y is equal to minus cx as the final answer. So we have either x is equal to cy or y is equal to cx as the final answer. Okay, y is equal to cx or x is equal to cy, both are same equivalent answer. So this 1 by y square and 1 by x square are also the integrating factor. So what is the meaning of integrating factor? That is, the given differential equation is not exact, but after multiplying this function, some function mu of xy, suppose mu xy, the differential equation becomes exact differential equation, or the given differential equation reduced to the exact differential equation by multiplying that factor, and such a factor is called integrating factor. So this topic gives this discussion gives the method also to how to solve the not non-exact differential equation. That is, if the differential equation is not differential equation, non-exact differential equation. So, but we can solve this equation by using this method. That is, we find the integrating factor and multiplying that integrating by multiplying that the given differential equation by that integrating factor, and then the given equation becomes exact differential equation, and then find its solution by using the formula integration m dx plus terms in n independent of x dy is equal to constant. Okay, so this is the procedure to obtain the solution in this topic. But the integrating factor, how we can find the integrating factor? So there are different methods to obtain the integrating factor. So we will see the that methods. So what is the remark? The number of integrating factors for the equation m dx plus n dy is equal to 0 are infinite. That is, equation has infinitely many integrating factor. That is, more than one integrating factor. Mu is integrating factor of the equation m dx plus n dy is equal to 0. Then mu in bracket m dx plus n dy is equal to 0 is exact differential equation. That is, if we multiply by that mu, if mu is integrating factor, if we multiply this equation by mu to both sides, then the result equation is what? This mu m dx plus mu n dy is equal to 0. Right? If you multiply or mu in bracket m dx plus n dy is equal to 0 is exact differential equation. So this is the definition of integrating factor. That is, if you multiply by the integrating factor, then the given non-exact differential equation becomes exact differential equation. Although an equation of the form m dx plus n dy is equal to 0 always has integrating factor. Okay, always has integrating factor. There is no general method of finding integrating factor. So every differential equation of this form m dx plus n dy is equal to 0 has integrating factor. There is no general method of finding integrating factor. There are different methods to find the integrating factor or finding integrating factor. That is depend on the example. That is on depend on the differential equation. So as the differential equation varies, the method of finding integrating factor also varies as per a differential equation. That is, depend on this type m dx plus n dy is equal to 0. So different differential equation has different integrating factor, or has different methods to obtain the integrating factor. So there are different methods. That is, there is no general method that is which is applicable all differential equation. That is, what there is no single method which is applicable to all not non-exact differential equation. So depends on the type of that differential equation, the method of integrating factor varies. So we have to search first. We have to identify that which method is applicable to the given differential equation to obtain the integrating factor. So here we explain some rules of finding integrating factor, or the methods to obtain integrating factor. So this is basic method, or it's called introspection, by introspection. So this is the basic method or first method of finding integrating factor. So there are this is the first method by introspection, and then this is the example of that type. And there are some rules of finding integrating factor. So rule number 1, 2, 3, 4, 5. So these are the 5 rules to obtain the integrating factor, and this is the one more method by introspection. So in all, we have to see 6 methods, the 5 rules and this basic introspection method. So in all, we have to find integrating factor by 6 methods. So in this chapter, so the first method is introspection method. That is the method to obtain the integrating factor. That is, by observation we can judge what is its integrating factor, what is its integrating factor. That is, if there is term y dx minus x dy in the differential equation, then divide by y square or divide by x square, because y dx minus x divided by y square is derivative of x by y. So in that case, if there is factor y dx minus x dy, then integrating factor is 1 by y square or 1 by x square is the integrating factor. So if the term is y dx minus x dy, but the term is y dx plus x dy, y dx plus x dy, x dy plus y dx plus term, then integrating factor is 1 by x into y, 1 by x into y, because then the integrating factor is 1 by x square, 1 by x square into y square. The factor is of this type, x dy plus y dx, or directly x dy plus y dx is derivative of x into y. So in order to obtain the integrating factor by inspection method, these rules are important. So first, what is these rules? What are these rules? These rules are dx, derivative of x by y is equal to y dx minus x divided by y square. So we use all these rules to obtain the integrating factor by inspection method. That is, if there is a factor of the type y dx minus x dy, then 1 by y square is the integrating factor, or 1 by x square is the integrating factor. So first rule is applicable here. So if you observe the problem, y dx minus x dy is equal to 0. So this is not exact differential equation, but what is the integrating factor? Is 1 by x square or 1 by y square is the integrating factor. By using this, we can observe that 1 by x square or 1 by y square is the integrating factor. Okay, so we can judge uh, uh, the function integrating factor from these rules, these notes. So derivative of x by y is y dx minus x divided by y square is u by v rule. We know that u by v rule. V derivative of u, derivative of x, u is what? Dx minus u means x, derivative of y is divided by y square, v square. So u by v rule, y by x is what? V means x, derivative of y is dy minus y dx divided by v square is x square. Derivative of tan inverse y by x. What is the derivative of tan inverse x? Is 1 by 1 plus x square. What is the derivative of tan inverse y by x? Is 1 by 1 plus y by x bracket square, means y square by x square, into derivative of y by x. So into derivative of y by x is what? Derivative of y by x is this, x dy minus y dx divided by x square. So after simplification, we have this answer. So what is the derivative of tan inverse y by x? 1 by 1 plus y by x bracket square into derivative of y by x, means into x dy minus y dx divided by x square. So simplify, we have this answer, x dy minus y dx divided by x square plus y square. So 1 by 1 plus x square, 1 by 1 plus y square by x square, x square is the LCM, and then we have x square plus y square, and then this x square and that x square get cancelled, and then we have this answer. Similarly, derivative of tan inverse x by y is this. What is the derivative of tan inverse x by y? 1 by 1 plus x by y bracket square, means x square by y square, into derivative of x by y. Derivative of x into derivative of x by y is this, y dx minus x divided by y square. We have this answer. So, or we can write this y dx minus x dy is negative of this. So it is the derivative of minus tan inverse y by x. Tan inverse x by y, or this is the derivative of tan inverse x by y, or this is the derivative of minus derivative in bracket minus tan inverse y by x. So log x by y derivative. So log x derivative is 1 by x. So log x by y derivative is what? 1 by x, x by y, 1 by x by y into derivative of x by y. So into derivative of x by y is this, y dx minus x divided by y square. So, and 1 by x by y means y by x. So we have y dx minus x divided by y by x. So 1 y get cancelled. So we have x into 1. So derivative of y x, instead of y by x by y, if y by x, then again is what? 1 by y by x means x by y into derivative of y by x into derivative of y by x is this. So we have this answer. So derivative of x into y is x dy plus y dx. So if there is term of this type x dy plus y dx, then it is the derivative of x into y. Then 1 by x into y is x dy plus y dx divided by x square into y square. Negative sign is there. So how we can find derivative of 1 by x into y is minus 1 by x into y bracket square. Like 1 by x derivative is minus 1 by x square. So its derivative is minus 1 by x into y bracket square, means 1 by x square into y square into derivative of x into y. Derivative of x into y is x dx, x dy plus y dx. So I have this answer. So derivative of x square by y. This is the not x y square by x square, right? Derivative of x square by y. So it is what? It is u by v root y. Derivative of x square is 2x dx minus x square, that is u. Derivative of y is dy divided by v square y square. So instead of this y square by x square, write x square by y. Then derivative of y square by x is this. Twice xy dy minus y square dx divided by x square by using u by v rule. Derivative of y square by x square is this by using u into v rule. So v means x square. Derivative of y square is 2y dy minus y square. Derivative of x square is 2x dx divided by x square square is x raised to 4. Similarly, derivative of x square by y square is this. Derivative of e raised to x by y is this. E raised to y by x is this. By using u by v rule, y e raised to x, derivative of e raised to x is e raised to x dx minus v means e raised to x, derivative of y is dy divided by y square. Derivative of log x square plus y square is 1 by x square plus y square into derivative of x square plus y square is twice x dx plus twice y dy. So use these hints to obtain the integrating factor by this method, first method, by inspection method. So there is some examples on these tricks. So use these tricks or these rules to obtain the integrating factor by inspection method. So here are some examples of that type. So solve 1 plus xy into y dx plus 1 minus xy x dy is equal to 0. So the given differential equation is this. And what is comparing this equation with m and n? So m is this 1 plus x into y, and n is 1 minus x into y into x. Here write dy into x. This is the n, and then multiply by y. So y plus x y square. So its derivative is dy by m by dy by y is y. Its derivative is 1, and the derivative of x y square, x is constant, and derivative of y square is 2y. So 2xy. And derivative multiplying by this x, and then we have the derivative with respect to x. Dy by n by dy by x is x derivative is 1 minus twice xy. So these two are not equal. Dy by m by dy by y is not equal to dy by n by dy. That is, the given equation is not exact differential equation. The given equation is not exact, but we can make it exact. We can reduce it to exact by multiplying integrating factor. So we have to find the integrating factor by inspection method. We have to find the by inspection method. By inspection method, we have to find the integrating factor. So what are the terms in the given equation can rearrange as? We rearrange the terms of this, split the terms and rearrange the terms. So how we can rearrange the terms? So there are term y dx and plus x dy. So y dx plus x dy, right in first two terms as a y dx plus x dy, and then another terms are x y square dx, and minus x square y dy as the second, as the third and fourth term is equal to 0. So in all there are 4 terms. So arrange that 4 terms like this: first 2 terms and this third and fourth terms. And then y dx plus x dy is exact because it is the derivative of x into y. So here we observe x dy plus y dx is derivative of x into y. So these first 2 terms are the derivative of x into y. So we have to find this third number and fourth number term are derivative of what? So for remaining part, multiplying by 1 by x square minus y square, 1 by x square into y square. Then equation 1 becomes, what do we have? The equation 1 becomes y dx plus x divided by x square into x square y square. And this is what? X y square dx minus x square y dy divided by x square y square. That is throughout multiply by 1 by x square into y square. So we have y dx plus x divided by x square into y square. So if you observe this term, x dy plus y dx divided by x square into y square is the derivative of 1 by x into y minus 1 by x into y. If you shift this negative sign to this, so x dy plus y dx divided by x square into y square is the derivative of minus 1 by x into y. So and if you observe this term, x dy minus y dx, so after cancelling, dividing x square y square, so here we get x, take x y as common from these two terms, x into y, and cancel that x into y to numerator denominator. So we have x dy, the term we have x dy, here is we have x dy, but it is negative term. And we have y dx minus x dy, so take negative sign common. So we have x dy minus y dx divided by x into y by taking negative sign. This term is negative and this term is positive. So take this term as positive and this term as negative and write here negative sign. And if you observe x dy minus y dx divided by x into y, here x dy, okay, x dy minus y dx, x dy minus y dx divided by x into y is log y by x. So x dy minus y dx divided by x into y. If you take this plus sign as it is, then we have what we have, y dx minus x divided by x into y. Again it is a y dx minus x divided by x into y is log x by y. So take this negative sign common, or don't take this negative sign common, take this plus as it is. Yeah, and then we have to write this log x by y. If you write here plus, then it is derivative of log x by y. But now what we have, this is minus derivative of x by y, because this what is derivative of 1 by x into y? 1 by x into y is this minus this bracket. So if we shift this negative sign to LHS, then we have y dx plus x divided by x square into y square is minus derivative of 1 by x into y, and minus derivative of this is log y by x is equal to 0, right? Is equal to 0. And then integrating both sides, so we have minus 1 by xy minus log y by x, derivative and integration get cancelled. So we have minus 1 by x. So right here step that integrating both sides, so we have minus 1 by x into y minus log y by x is equal to c1 as the constant of integration. Throughout cancel the negative side. So suppose, so we have the new constant c1 dash of c1. Here take c1 dash and then minus c1 dash as c1. Throughout change the sign, and then log e raised to 1 by x into y is equal to log, plus log y by x is equal to log c. So this is we can write this as log e raised to x, e raised to 1 by x into y. So what is the simplification of this? Log a raised to m is m into log a. So we have 1 by x into y. Its simplification is 1 by x into y into log e. Log e is 1. That is, we have this factor. And then log a plus log b is log a into b. So log y by x into e raised to 1 by x into y is equal to log c as new constant. Suppose this c1 as log c, and then cancel log of both sides. So we have y by x e raised to x by y is equal to c, or this is the final answer. Take shift this x to RHS, or this is the final answer. No need to write these steps, further steps. So after integrating we have this. So this is the final answer. Either this, write this as the final answer, or 1 by x into y log y by x is equal to c. No need to write these steps. So this is the general solution or required solution of the given differential equation. So by introspection method, we can find, by using these tricks, these formulas, we can find the integrating factor of any differential equation which is not exact differential equation. So this is the method how we can find the integrating factor by uh, inspection method. There are some rules which are useful to determine integrating factors. In particular cases, classes of differential equation. Okay, m dx plus n dy is equal to 0 is the given equation. Then we can find integrating factor by the following rules. So there are again 5 rules. So we see these first these 5 rules, and then we will see the examples of all these 5 rules, as well as the example on the first method, that is the integrating factor by inspection method. So in all there are 6 methods in inspection method, and these 5 rules means these 5 methods. So in all there are 6 methods to find integrating factor. So in the next lecture we will see all these 5 rules, and then the mixed examples of all these 6 methods. So in the further coming lectures we will see the remaining 5 rules and the mixed examples of these 6 methods to find integrating factor. So this is the topic, that equation reducible to exact differential equation, that is by integrating factor. So there are in all 6 methods to obtain the solution by using this method. So we will see the remaining rules and examples in the next lecture.